Hi everyone, this is the model answer for the density foundation question. So, it says, two large semi-precious stones are discovered. A student is asked to find out what material each of the two stones is made of. The student does this by determining the density of the material of each stone. Figure 1 shows the two stones. So stone A is quite an irregular shape. Stone B is quite regular, like a cuboid. The student wants to measure the volume of stone A. Stone A cannot be measured using a meter rule as the stone is an irregular shape, like we discussed before. Describe how the student could determine the volume of stone A by putting it in water. So it's giving you a little bit of a hint here that you need to use water. Okay, so this should remind you of the density required practical where you have a displacement can or a eureka can. You fill this with water up to the base of the spout, and then when you put your object inside, your irregular shaped object, it pushes the water up and down the spout. You then can collect this in a measuring cylinder and measure the volume of water. And the volume of water that comes out of the spout is exactly the same as the volume of the stone. So what we've got to do is we've got to try and write this down so we get 3 marks. So the first mark is for saying use a displacement can or a eureka can filled with water. The second mark is for saying collect the water that is displaced by the stone. So that's the water that is pushed out through the spout of the tube. And then the last one, we need some way of measuring that. So we need to be saying what piece of equipment we use. So we're going to measure the volume of the water with a measuring cylinder. Measure the volume of the water with a measuring cylinder. Now be careful with questions like these because you could go off on a tangent and you could start writing about how you would work out the density of the stone, etc. It is just asking how we get volume at this point. Okay, so be careful you don't go off on a massive tangent. Next part of the question. The student makes measurements of stone B using a meter rule. The measurements of stone B are shown in figure 2. So we've got the dimensions of this regular shaped object. Which piece of equipment could the student use to get more accurate measurements of the length of stone B? We're ticking 1 box. Okay, so make sure you choose 1, not more than 1. So electric balance, microscope, Newton meter or vernier calipers. So if we go through one by one, an electric balance will be used to measure mass, so it's not that one. Microscope is used to look at really small things, microscopic objects, so it's not that one. A Newton meter is used to measure force. The only one here that is used to measure length is a vernier caliper. So that is the box that I would tick. Use the following equation to calculate the volume of stone B in centimetres. Alright, so let's have a look at our stone B. I want its length, which is 3.5, times by its width, which is 3.2, times by its height, which is 1. Okay, so then you need to do your calculation. It'd be 3.5 times 3.2 times by 1, and the answer is 11.2. centimetre cubed. Okay. Now it's telling us that the mass of stone B is 56 grams. Okay, and it's saying also use the answer from part C. So we're going to be using this somewhere. To calculate the density of the stone in grams per centimetre cubed, use the following equation. Density is mass divided by volume. Okay, now it's telling us the units we want to measure it in. Mass needs to be in grams and volume needs to be in centimetre cubed. You can also have density in kilograms per metre cubed, so it's always worth double checking what the units are saying. So if we look at the mass in the question, we've got 56. Just double check that it is in grams, which it is. So I can use 56 just like that. And then the volume is 11.2, and that's centimetre cubed, which is what I wanted in. So for density, I'm going to have to do 56 divided by 11.2, and the answer would be, if you round it, 5. Okay, so make sure that you are checking your calculations, checking your units as well. And then we're on to the last part of the question, which is section E. The student calculates the density of the material stone A is made of as 5.2 grams per centimetre cubed. The student looks up the density of some materials in a textbook. Figure 3 shows the information. Okay, so we've got amber and its density between 1.1 and 1.2. Cubic zirconia between 5.5 and 5.9. Garnet 3.8 and 3.9. And then hematite 5.1 and 5.3. Which material is stone A made of? So it's 5.2 grams. So you're looking where that 5.2 is going to lie, and it's actually within this section. So the stone must be made from hematite. Okay, well done guys for having a go at those questions. If you do need anything, you can always email me and I'll get back to you about it. Thank you.